Welcome, ladies and gentlemen. This is my assignment from Duke University in collaboration with Coursera with the course Human Factors in AI. The assignment is about design user experience and evaluate privacy and ethical implications. I'm talking about here about a software stack which has nearly 6,300 parameters which need to be set according to customer expectation. The values of the parameters are depending on the customer itself, the system architecture, the underlying hardware, and the application level on top of the software stack. The current solution is, when starting with an unconfigured stack, all parameters have to be set manually. Heuristic approaches to start from another customer stack. But changes due to different architecture, hardware application require also a massive manual change of parameters. The problem statement is the task or the improvement is to predict parameter values according to customer system architecture, underlying hardware and application level on top of software stack. First of all, is there a problem? Yes, there is a problem. Configuring a software stack, it doesn't matter if starting from an existing project or from scratch, requires massive manual effort. This activity is time-consuming, prone to errors, and has, in case of changing customer requirements, it will lead to a time delay. Combined stacks in an architecture need to be synchronized continuously. Can machine learning help to solve the problem? Yes, it can. ML can identify existing configurations such as parameters which are similar based on environmental changes, for example hardware, and suggest or pre-configure these parameter values. Does someone care? Stakeholders of software developers and their leadership, as well as the customers, due to shortened development cycles and thus shortened time to market and reduced amount of money spent. User experience design. The user input. The additional feature will be built as a plugin for the development suite. It will pre-fill parameters with suggested value. The suggested parameters will have another color, for example red or blue, that the user can identify if this is a suggested parameter or manual entered one. Transparency. The user will select the specific module he would like to configure. Within this module, all parameters value will be suggested based on the model output. The user will check the suggested value and confirm or enter differing values. If the values have been confirmed, the color will switch back to the standard color, for example black, to show the user that this parameter has been checked. Uncertainty. If a new parameter pops up, which is not yet covered by the model prediction, it will be marked with red color to give the user a better hint to check the settings. The model will retrain regularly using the configured parameter values and in a cloud-based system approach to make sure to be in sync with other configurations in real time used within the same system. Privacy configuration. The parameters values are based on different intellectual property. Some are based on underlying hardware, some are on customer requirements, or some are based on system architecture and thus the experience from the team or from the customer. Applicable privacy laws. GDPR, General Data Protection Regulation, imposes strict data protection rules to ensure privacy. Obligations are to implement security measures to ensure considerations of privacy with different types of IP. Ethical considerations. Sources of bias. There are two main sources of bias in this project: data bias and representation by data. The parameter values are based on different sets of historical data and may contain specific projects for a single customer, its users, or a specific type of projects more often. Algorithm bias, measurement bias. The choice of the algorithm and the provided learning parameters can influence a modeling bias. Goals in ethical AI are fairness. The training data has to represent all types of customer projects and types of users and types of customers. Accountability, error reporting and monitoring of module outputs. Transparency, establish previous described color system to indicate estimated parameters, verified parameters, and uncertain parameters with a different color. Thanks for watching.